April 16, 2014, 8:48 a.m. The Yellow Sea conditions are calm. Visibility is good.
The MV Sewol, a RoPax ferry, purchased from Japan, retired and bought cheap by Cheonghaejin Marine.
It's carrying 476 people. 325 are students from Danwon High School on a field trip to Jeju Island.
It's also carrying 2,142 tons of cargo that is strictly illegal. The licensed limit was only 987 tons.
They are running heavy, over double the legal limit. To compensate, they dump the ballast water.
Ballast keeps the ship stable. They dumped it to hide the overload from port inspectors. Profit over physics.
The ship approaches the main goal channel. The current is strong here. The helmsman executes a turn.
A routine turn 5 degrees, but the steering gear is old. The ship swings harder than intended.
Centrifugal force kicks in. The ship leans to port, just a few degrees at first.
But there's no ballast to push back, and those 2,000 tons of cargo, they aren't secured properly.
The chains snap. Cars, containers, and steel beams slide across the deck. The center of gravity shifts instantly.
The list increases. 10 degrees, 20 degrees. Passengers are sliding down the hallways.
At this angle, a normal ship corrects itself. The hull shape pushes back against the water. Righting arm stability.
The seawall doesn't correct. It keeps leaning. The company added a gallery deck upstairs to sell more tickets.
That renovation raised the center of gravity. The ship is top-heavy. It's a pendulum that got stuck on the upswing.
The captain is on the bridge. The crew is panicking. They tell the students to stay in their cabins.
Stay put. Worst order in maritime history. The ship is already past the point of no return.
Because of a design flaw that nobody at the registry bothered to flag, the air supply.
We are talking about the engine room ventilation ducts, big open pipes on the car deck.
They were positioned too low on the aft deck, right where the waterline was rising.
It's a ro-ro ferry. Roll on, roll off, massive open decks for cars.
That means no internal walls on the vehicle deck. Free surface effect, water sloshes everywhere.
At a 4-5 degree list, those vents hit the water. They stop sucking air and start sucking the sea.
It's a direct line to the engine room, bypassing all the watertight bulkheads. The pumps fail. There is no power to fight the water. The ship is now heavy on the bottom and the side.
Once the water enters those vents, it hits the open deck. It destabilizes the entire vessel.
And the crew knew. They abandoned ship first. The captain was one of the first off.
He knew the physics. He felt the ship lurch. He knew it wasn't coming back.
He left the kids behind to protect the company's liability, a distinct failure of command.
It's not just sinking, it's capsizing. The speed of the roll accelerates.
And the cost? 304 dead. A payout of $850 million in insurance and compensation.
But the physics of the disaster started months before the turn. It started in the shipyard.
It started with a spreadsheet. How much cargo can we fit if we ignore safety standards?
Today we dissect the structural failure. Why did the ship lose its righting arm?
And I'll walk you through the logic of the men who signed the death warrants, the logistics of negligence.
The Sewol didn't have a chance. Once that cargo shifted, the vents were doomed.
A floating coffin. Let's open up the blueprints. This is kinetic fall.
Prepare for immersion. We need to dissect the structural modification that turned the Sewol from a functional ferry into a ticking time bomb, specifically focusing on the vertical center of gravity, or VCG. When Cheonghaejin Marine bought this ship from Japan, they immediately added an entire gallery deck on top of the existing superstructure to increase passenger capacity, adding nearly 200 tons of steel and weight to the highest point of the vessel, which fundamentally ruined the ship's ability to right itself after a turn.
That renovation wasn't just an engineering oversight, it was a calculated financial gamble to maximize ticket sales during the peak holiday seasons between Incheon and Jeju by adding those extra cabins. They drastically increased the potential revenue per trip, but to keep the ship floating within legal limits, they had to make a fatal trade-off. They had to carry less cargo or less ballast water to compensate for the new, top-heavy steel structure.
The physics of a turn requires a ship to lean, but the righting arm, the force that pushes the ship back upright, was practically non-existent because they had drained the ballast tanks to dangerously low levels. Without that low-down water weight to act as a counterbalance, the moment the helmsman initiated that sharp turn, the centrifugal force took over completely, causing the ship to heel over way past the critical angle of no return.
They drained those ballast tanks intentionally because they were carrying 2,142 tons of cargo, which was more than double the licensed limit of 987 tons, and they needed to hide that extra weight from the port inspectors. If the ship sat too low in the water, the plimsoll line would have been submerged, triggering an inspection, so they pumped out the safety water to artificially raise the ship and hide their illegal profits.
Once the ship heeled to port, the internal disaster began on the car decks, where the cargo lashing system failed immediately because it wasn't designed for that amount of weight. We are talking about massive steel beams, cars, and heavy containers snapping their chains and sliding violently to the port side, which created a massive shift in gravity that pinned the ship on its side, preventing it from ever rolling back to an even keel.
The investigation revealed that the lashing crew used simple ropes instead of legitimate steel chains and turnbuckles for much of the heavy cargo, and the D-rings on the deck were completely rusted out. The company had slashed the maintenance budget to the bone, meaning the only thing holding tons of steel in place was cheap rope and friction, which stands zero chance against the kinetic energy of a 6,000-ton vessel lurching in a current.
This brings us to the down-flooding point, which is the specific angle where water starts entering the hull through non-watertight openings. And on the Sewol, this was fatally designed. The air intake vents for the engine room were located on the aft vehicle deck, extremely close to the waterline, and they were essentially wide-open tunnels that led directly into the heart of the ship's machinery spaces without any watertight dampers.
Usually, these vents are positioned much higher or have automatic closure systems, but on the Sewol, they were left vulnerable because nobody anticipated a list of this magnitude. As soon as the ship tipped past 40 degrees, those vents dipped below the surface, and the ocean began pouring directly into the engine room at a rate of thousands of gallons per minute, killing the generators and the pumps instantly.
Once the engine room floods, you lose all propulsion, and more importantly, you lose the hydraulic power needed to operate any potential ballast pumps or steering corrections. The free surface effect of that water sloshing around inside the engine room destabilized the ship even further, accelerating the capsizing speed and trapping everyone inside as the vessel began its final inversion.
And while the physics were sealing the ship's fate, the captain and the senior crew were already scrambling out of the bridge, abandoning the bridge without issuing a mayday to the passengers. They knew exactly how much illegal cargo was on board and how unstable the ship was, so their calculation was purely self-preservation, leaving hundreds of students waiting in their cabins for instructions that would never come.
The immediate aftermath of the capsizing revealed a catastrophic failure in the rescue operation's tactical execution, because while the ship was inverted, it didn't sink completely for hours. There were known air pockets trapped inside the hull, specifically in the passenger cabins where the students were told to wait, but the Coast Guard lacked the specialized diving equipment or the structural blueprints to breach the hull and access those potential survivors before the air ran out, or the water pressure became insurmountable.
While the divers were failing to enter the hull, the political fallout was instantaneous and brutal, leading to the complete dismantling of the South Korean Coast Guard by the president. The investigation exposed a culture of collusion between the regulators and the shipping industry, where safety certificates were essentially bought and sold, proving that the entire maritime safety infrastructure was a hollow shell designed to protect corporate liability rather than human life.
The survival verdict here is grim but necessary. In a maritime emergency, situational awareness must override authority, because the moment that ship passed a 15-degree list, the stay-put order became a death sentence. Physics dictates that once a vessel loses its righting arm, movement becomes exponentially harder with every passing second. You have to scramble to the highest point of the deck immediately, because waiting for confirmation from a crew that has already abandoned the bridge is a fatal tactical error.
The psychological component is what killed those students, as they were conditioned by a hierarchical society to obey authority figures without question, even when their own instincts were screaming that the situation was critical. The verdict from an intelligence perspective is that you must always assess the competence of command. If the people in charge are not communicating clearly or are visibly panicking, you are effectively on your own, and you need to make a unilateral decision to evacuate.
Technically, the Sewol is a case study in unstable equilibrium, where a single mechanical failure, the steering gear, triggered a cascade of structural flaws that had been engineered into the ship months prior. If you are ever on a ferry that feels top-heavy or rolls sluggishly in calm waters, that is a tactile warning sign that the vessel's center of gravity is compromised, and you should identify your exit routes before the ship even leaves the dock.
Financially, the legacy of the Sewol is the destruction of the Chongkaijin Marine Company and the mysterious death of its owner, Yo Bai-nong-yoon, who was found dead in a field while on the run. It serves as a stark reminder that in the logistics of the dark economy, cutting costs on safety measures like ballast, water, and cargo securing inevitably leads to a black swan event where the financial ruin far outweighs the meager profits gained by breaking the rules.
The ocean doesn't negotiate with physics, and it doesn't care about your profit margins or your ticket sales. When the mechanism fails, gravity takes over, and the only thing that matters is your ability to move fast and disregard bad orders.
Trust your instincts, audit your surroundings, and never let a corporation's bottom line dictate your survival strategy. Stay sharp.
Check your gear,